Alright, now we are getting into something called pitch. Pitch, 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 pitch. Pitch. With a P, not a B. But pitch is, pitch. Alright, so it's kind of hard to explain the concept of pitch. But we do know what frequency is. Frequency is how fast something vibrates or cycles. So this has a higher frequency than this. Make sense? Now, pitch is how we perceive frequency. So this one down here, which has lower hertz or cycles per second, is perceived differently or interpreted, say, this doesn't sound the same as this one. Now this is because it vibrates faster and we hear it faster. Anyways, this one is going to be perceived as a lower pitched noise. So pitch is the sound we get from frequencies. That is a low pitched sound because it vibrates slowly. Now this up here on this keyboard is a higher pitched sound. That is because it vibrates quickly. So the faster something vibrates, the higher pitched it sounds. And again, pitch is just the perception of different frequencies. So for example, we have all these different pitches. We have a guitar. These up here are lower pitched, than these up here. Because here, let me give you some theory right here. So we have a string that we pluck it and it vibrates across this board. If we press our finger like halfway down, the string becomes shorter, which means it vibrates more quickly because it doesn't have to take a big of a cycle. For example, we pluck this top string, the 6th string. So now we still have an E, it just vibrates twice as fast. And we interpret that as higher pitched. So now the strings kind of relate to these a little bit more. If we have a string on a stringed instrument and it's this long, dang, my marker's failing. No wonder nobody uses dry erase boards. They stink. So we have this string, and let's say it's at E. Then we have this string, and it's at E. And you're like, whoa, there's 2 E's. How's that even possible? Well, they're not technically the same E's. Because if we take a look at this, on this keyboard, it displays it nicely. We have an E here. Whoops. E6. And if we go down a bit, we have E5. That is called pitch notation to differentiate between different pitches. So we don't just have A. We have A1, A2, A3, A4, A5. And we will get into that in another video coming up shortly. Okay. We have this graph here, and it looks like this. So let me make a positive one here. Here's the positive, here's the negative, positive, negative, positive, negative. And by positive, negative, I just mean compression and rarefaction. I don't even know why I tried writing this. So now, if we have something that vibrates twice as fast, I don't even know if I can be able to draw this. Okay, so now we have, say this vibrates twice as fast, we're going to have 2 cycles for every 1 cycle up here. If we alter it so it's not quite double, such as it's not double the frequency, we can still have it sound nicely, because let's say this one, this will vibrate 3 times every time this vibrates twice, which means it doesn't sound the same, but at some points they're both going together. They're both going to hit high points at the same time. See you in the next video where we will be talking about, I can't remember, but it's going to be awesome. So click subscribe, follow me on Twitter, whatever. Bye.